All right, so we are diving into 5.3, which is all about the definite integrals and its relationship to the term antiderivatives. All right, in my opinion, they're pretty synonymous terms, with a little bit of, I guess, a little bit of difference in there in terms of how they are used. But as we dive into chapter 6, we're going to be really start going into more of the antiderivative portion of things. How can we take any function and almost reverse the process of taking the derivatives and find out what the original function was? All right, so given a derivative, can you find its original function? All right, before we get there, we're going to continue to dive farther into integration. And our goals throughout 5.3 are to identify the rules of integration, use the average value theorem, and use the mean value theorem of definite integrals. This video specifically is going to look into simply the rules of integration. So I'm going to lay them out one by one for us, and it's going to give us a good kind of just a preface for the rest of this section and our goal that we're dealing with here. So the first thing we're going to talk about is called the order of integration. All right, so the first thing that we're going to look at, rule number 1, if it'll write for me, there we go. All right, order of integration. And basically what this is referring to is the order of the upper and the lower limits. So what this says is that if we have a lower limit a and upper limit b of a function f of x from dx, this is the exact same thing as making the opposite of from b to a. All right, from b to a. All right, so if we have the order of integration, that's all we're kind of showing there, is that it's the opposite happening. So if we're going from a to b in our lower to upper limits of f of x, if we take that negative or the opposite of it, it really is just flopping your upper and lower limits. And think about it. Think what we know about the constant so far. The constant is the number itself, the constant multiplied by your higher limit minus your lower limit, okay? And so if you reverse the upper and the lower limit, you would just make it the opposite. You just make it negative if it was positive, or positive if it was negative, okay? And that's all the order of integration is talking about here. All right, moving right along. The second rule we're going to look into is called the zero rule. All right, zero rule for integration. What this shows is that if you are basically not changing your uppers and lower limits, your integral will result in 0. So let's say the upper limit and the lower limit are the exact same thing. Well, when you subtract them, they're going to cancel on out and give us 0. All right. The third one on our list that we're going to look into is called the constant multiple rule. So let's say we're having a constant multiple being attached to a function. So it looks something of the nature here. The function from a to b, we'll call k the constant multiple, and we're going to keep our f of x times dx. You can basically take, not basically, you can take your constant on the outside of your integral and do so as such. This is going to help us in the future to make our lives a lot easier when finding the antiderivatives of functions. There's 3 down. Moving right along. The fourth one that we are going to look into, we call the sum and difference. So let's say we are taking the sum or difference of 2 separate functions. So let's say it looks something like this. From a to b of f of x plus or minus g of x, I don't care, sum or difference, all right, of d or dx, we can rewrite this as 2 separate integrals. So this would be equal to the integral from a to b of f of x plus or minus the integral of a to b of g of x, okay? And I can't forget this dx here, okay? So we can separate it using our sum and difference. The next one we're going to call is what the additive property, all right, or additive rule. So our additive rule that we are going to look into. Additive, we'll call it additivity, I guess. Additivity, same concept there. Okay? So let's say we're given the following integral. It goes from a to b. Once again, same with f of x. Let's say there's another addition of that function from b to c of f of x. All right, this is the same thing as combining, kind of almost reminds me of the transitive property in geometry. This is the same thing as combining from a to c of f of x d of x. So there's our additive, or the rule of additivity. Rule of additivity. All right. The next two that we're going to look into as we kind of wrap things up a little bit, yes, they are rules, but they help us kind of, I think about it a little bit in a different concept here. The next one we're talking about, it's called the max or min inequality. Max or min inequality. All right, so we're basically saying, let's say if the max f, all right, and the min f, or the maximum minimum values of f, all right, we can say this. So, all right, so you're thinking to yourself, all right, you have a maximum value for f. You have a minimum value for f. And so what we can say is that we know the minimum is less than the integral, which is still less than the maximum. So let's see if we write this on out again. So max or min, the minimum of f times your b minus a, we're still in that same interval, b to a, or a to b, is less than or possibly equal to the integral from a to b of f of x dx, which is less than, obviously, the max of f times b minus a. Okay? So the minimum of f multiplied by your upper and lower limits is less than or equal to your integral of f from a to b, which is in turn less than your max of f multiplied by b minus a, which makes sense. I mean, you would have to think that the area under the curve is less than the maximum but greater than the minimum. Okay, it's kind of a common sense one that happens in there as well too. All right. And the last one we don't use too often, but it'll come up every once in a while from time to time, so we'll make sure that we're all on the same page here with this one. All right, it's called our domination. Domination. Rule of integration. All right, and what this is basically showing is if it's a comparison between two functions. So let's happen to say we have two functions. We'll call them f of x and g of x, in which f of x is greater than or equal to g of x on an interval from a to b. What this implies is that the integral from a to b of f of x, the area under that curve, all right, should be greater than, and in fact is greater than, the function g of x on that same interval from a to b. Okay? So what this, again, is just kind of one common sense. If f is bigger than g, then the area under that curve of f should be bigger than that exact same interval under g. All right. It takes it just one little step further here in case something happens like this. Let's say, for instance, f of x is just simply greater than or equal to 0. And we're not comparing it to another function, still on that same interval from a to b. What this implies is it says that, hey, if we have the function f being bigger than 0, what that means is that from a to b, you must have an area under that curve that is greater than or equal to 0 as well. All right? All right, guys, so that is our 7 rules for integration. Now, this video is really just focused around, so make sure that you're very familiar with these, and especially some of those top ones that we really kind of talked about. That's going to help as we get into more of the antiderivatives and evaluating integrals a little bit more intensely. All right.